Thank you for joining this lesson. We are going to study loci and geometrical constructions. We are given a question here which says that using a ruler and a pair of compasses only, construct a parallelogram ABCD such that AB is 9 centimeters, AD 7 centimeters, and angle BAD 60 degrees. So we can first of all come up with a sketch of this parallelogram such that, remember, parallelogram is a quadrilateral with two pairs of parallel sides. So we are told that AB is 9 centimeters and AD 7 centimeters. Then angle BAD is 60 degrees. 60 degrees. So now we can come up with this kind of a parallelogram. So we first of all going to draw line AB. Line AB. This is AB. Therefore, assuming that this is our A, we should measure an arc. We should measure an arc which is equal to 9 centimeters. Which is equal to 9 centimeters, so that we may locate our B. Therefore, standing here, I measure 9 centimeters on my ruler. And now I use that arc. Standing at A, I make an arc. So this is going to be my B, 9 centimeters. Again, we are given an angle, BAD, 60 degrees. So at A, we construct 60 degrees from the inner side of the line. So standing here again, I make an arc. Then using the same radius, I stand here and cut that arc. Now when I join this point of intersection with A, I will be getting an angle which is automatically equal to 60 degrees. Therefore, this is 60 degrees without a protractor. 60 degrees. Now that I got my 60 degrees there, I can now measure a length of 7 centimeters from A, 7 centimeters, so that I find where D is. This will be D because I've measured 7 centimeters. Something you should know about a parallelogram is that this line AD should be parallel to the line BC. Therefore, if we have measured 60 here, then we should measure another 60, or rather construct another 60, so that now we have AD becoming parallel to BC. Therefore, standing here, I make another arc. So now I stand on this side and cut the same arc. If I produce this line, I will have constructed another 60 degrees, and these two lines will be parallel to one another. This is 60 degrees. So this line and this one are parallel. And now that we have the length of AD, then the length of BC should still be the same, 7 centimeters, equal and parallel. 7 centimeters. So standing here, I make an arc, and if this is 7 centimeters, then I'll have identified my point C. And now that I have C and D, I can join them to make the complete parallelogram. So now this will be my diagram now. The parallelogram is fully constructed. It's fully constructed. Now the other thing is in part B of the question, which says construct on the same diagram, construct the locus of a point P such that P is equidistant from AB and AD. If you are told to construct the locus of points which are equidistant from two given lines, then if the two lines are making an angle, we bisect the angle between these two lines, AB, which is here, and AD, which is here. The angle they are making is this 60, so we bisect it. We bisect the angle of 60, and because we had already made an arc, we can just stand here, we make another arc, and standing on the other side, we cut the first arc. Now joining the arc to A, we will have bisected. We will have bisected that angle, and that will be the locus. That will be the locus of point P. The locus of point P, equidistant from AD and AB. The bisection of the angle between the two lines. That is the locus constructed. Part 2, the locus of point Q, such that Q is equidistant from B and C. If you are told to construct the locus of points equidistant from 2 points, B and C, then we bisect the line joining B and C perpendicularly. So when we construct a perpendicular bisector to BC, we will have constructed the locus of points which are equidistant from B and also from C. Therefore, we make an arc. We make an arc at this point. We make another arc on this side, so that now using the same arc we can stand at B and cut the original arcs. Cut the original arcs such that now if the two arcs are joined together, we will get a perpendicular bisector to BC, and this will be the locus of points which are equidistant from B and C. Equidistant from B and C. Therefore, this will be the locus of points Q. Points equidistant from both B and C. The locus is already constructed. Part 2 is already done. Now part 3. The locus of T, such that T is equidistant from AB and DC. AB and DC. Now these are two lines which are not intersecting. Therefore, points which are equidistant from them is when we draw a line which is passing at the middle of DC and AB. Therefore, we're going to bisect these two lines. Bisect these two lines. So we draw 3.5 centimeters. Since AD is 7, now we draw 3.5 centimeters. Standing here, 3.5 centimeters. And standing on the other side, 3.5 centimeters. Now with 3.5 centimeters, we will have drawn a locus of points which are all equidistant. These are points which are equidistant from DC and also AB. DC and also AB. This parallel line to the given lines. So this one will be the locus of point, we said point T. So locus of T is this one, locus of Q, this one, and locus of P, this one. Finally, we are told to shade the region bounded by the locus of P, Q, and T. So P, Q, and T, they are making a common area here, which is being bounded. And finally, we determine its area. Therefore, to get area of this common region, we are going, because we can see it is a triangle, we can use the simple methods of getting area of a triangle. By first of all, we can choose to get one of the angles, and I will get the angle at this point. So when I try to measure this angle, I realize it is 30 degrees. So if we have 30 degrees, then I can measure two of the lines which are making up the angle. Therefore, this line from here up to this point, I'm finding it exactly 3 centimeters. This is 3 centimeters. Then the other angle, okay, the other line making the same angle is this one. Therefore, when I measure, I find it at 5.4. This is 5.4 centimeters. Therefore, now, area of that common region can be given by half times one side times the other side, then sine of the angle at the center of the two given sides. Half multiplied by 5.4 multiplied by 3, the sine of 30 degrees. This is going to give us 4.05 square centimeters.